Thanks, Matthew. Grab one of each and then a calculator if you need it. Hi, Hannah. How you doing? Grab one of each, calculator if you need it. Hi, Takara. Hi, Audrey. All right, you are in your seat. Jamari, take a seat. And you have started your do now. Habib, get to it. Thank you, Alex. Okay, pause where you are. It's okay if you were not all the way through. We did okay with 1, 2, and 3. These should be relationships that you know by heart. So 100% of us should be getting 1, 2, and 3 correct. Volume and pressure at constant temperature. Alyssa? Good. Make sure it says inversely, not indirectly on your paper. Constant pressure, temperature, and volume. Alex Lamb?
Directly proportional.
Good. And then temperature and pressure at constant volume. Nakai? Beautiful. Alana? So, make sure you have all of these. We're going to practice them in just a moment. For your next piece, you should have gotten 120 liters. Give me a thumbs up if you got that. Great. Okay, we are going to practice each of those relationships with our partner before we do our practice drill. So, with your partner, what happens as you increase temperature to the pressure of a gas and why based on particle motion? Tell them, go. Okay, pause where you are. All right, tell me what's happening, Sterling.
So you said temperature and pressure, right? Okay, so the temperature increases, meaning that the average kinetic energy is increasing, which means the particles are moving faster, and that's making more wall collisions, causing an increase in pressure.
Beautiful. That was excellently said. Okay, temperature and volume in an elastic container. Tell your partner, go.
Elastic container.
Temperature and volume directly.
Why? What happens? Say it again. Good. Yep. Okay, pause where you are. Tell me what's happening in this relationship, Jakara.
As the temperature increases, the average kinetic energy increases as well, causing the particles to hit the walls of the container. Since it's elastic, it will cause the particles hitting inside the container will cause the container to change its shape, increasing the volume.
Beautiful. Thanks, Shakira. China and Jakara for that. That was perfect. And China and Sterling. We forgot to China and Sterling, I'm sorry. Okay, last one. Pressure and volume. So as I decrease the volume of a container, what happens? Tell your partner, go.
If I decrease the volume of the container, then that means the pressure.
Habib, cell phone away. Okay, I'll give you a calculator. So as I decrease the volume, what's happening?
Pressure increases.
Decreases. I mean increases.
Why?
Because there's less space for the particles to move around, so there's more collisions of this.
Good. Habib, I'm going to call on you. Okay, bring it back in 3, 2, and 1. Tell me what happens here, Habib, in the back.
When volume decreases, there's less room for the particles to move around, so there's more collision with the wall, and
Which causes what?
increase in pressure.
Beautiful. Some of us talked about average kinetic energy in this one. We said that the particles were moving faster. Why is that incorrect to say when we're talking about pressure and volume? I love the hands. Alana?
Because the average kinetic energy
Beautiful. So when the temperature is constant, our particles aren't moving faster, they just have less space or more space to move around in. Okay, with your partner, you are going to practice those 3 relationships. All you should say is, as volume increases, pressure does blank. As temperature increases, pressure does blank. And then remind your partner how we convert between Celsius and Kelvin. You have 30 seconds, go.
Temperature goes up, volume goes up. When pressure goes up, volume goes down. And then how you get from kinetic energy to
And so today we're going to look at an equation where if we know our initial conditions and then we take a gas and we change those conditions, so we decrease the temperature, for example, we increase the pressure, then we can find the final volume. And that is called the combined gas law. So we're going to write a couple of things in our notebook. The first thing you're going to write is the equation itself, which is P1 V1 over T1 equals P2 V2 over T2. I'll put it on the board once this comes on. There it goes. All right, so P1 V1 over T1 equals P2 V2 over T2. So all this equation is saying is these are our initial conditions. So if we're talking about that nitrogen gas we're trying to use, its initial pressure, its initial volume, its initial temperature. And then these are our final conditions. Final conditions. So once I decrease the temperature to something very, very low, and I increase the pressure, then we could find out what my final volume is. Now, we can only use this equation if we're looking at the same sample of gas. So same gas. And so far in class, we've learned about Celsius and Kelvin. So with your partner, you're going to answer 5 questions about Celsius and Kelvin. You're not going to write these down, just with your partner. But the goal is that we understand why we use Kelvin temperature in our combined gas law and not Celsius. So answer each of these questions with your partner out loud. Go ahead.
I know it wasn't zero temperature, it was like when there's no average, there's no like particle movement. Yeah, so that, and then the average is gonna be wrong. And then how do you convert between Celsius and Kelvin? Either adding 200 and something.
Okay, bring your conversations forward.
lucky.
So first, Celsius temperature scale is based on what? Matthew?
The freezing point of water.
And the?
What?
The freezing point and the?
Boiling point of water?
Good. What's the freezing point of water?
Yes, sure.
0 degrees Celsius,
Thank you. And the boiling point?
100 degrees Celsius.
Beautiful. Okay, so that's the Celsius scale. What about the Kelvin scale? What's that based on? Brianna?
Based on particle motion.
And what does 0 Kelvin tell us, Will?
0 particle motion.
Great. And then if I'm increasing the temperature, what do I know? Alex P?
Means there's more particle motion.
Beautiful. And then finally, how do I convert between them, Evan?
Add and subtract 2 or 17.
Okay, so we've been talking about each of these gas laws, and in each one of them, we've been talking about particle motion. So when we use our temperature scale, we want to use the one that indicates or communicates particle motion to us, which is Kelvin. So that's why we will always, always, always use Kelvin for our gas laws. So let's make a note of that in our notebook. So beside of temperature, beside of T2, we're going to write convert to Kelvin. Convert to Kelvin, always.